This PowerPoint looks at half reactions. That means either oxidation or reduction. And so we're just going to learn a bit about what half reactions entail. Half reaction has to be either reduction or oxidation. Anytime the electrons are left of the arrow, it is going to be a reduction. And anytime electrons are to the right of the arrow, it has to be an oxidation half reaction. Easy stuff. Get used to it. Remember, you have a chart that says table of reduction potentials. And notice it says reduction potentials. It's talking about the forward, and the electrons are all left. Half reactions will include electrons. When we get to redox reactions, they don't include electrons. So, table of half reactions, you have a sheet. This stuff I've talked about in another PowerPoint. Forward reaction is always reduction, it's always a gain of electrons, it's always a drop in charge. And a reverse reaction is always oxidation, you're always losing electrons, and the charge is always going up. And this is the beauty of redox. If you know about reduction, everything flips, becomes the opposite for oxidation. So there are ways of remembering this. Leo, the lion, says grr. Believe it or not, this is something we use in Chemistry 12. Loss of electrons is oxidation. Grr, gain of electrons, is reduction. So if you're struggling with this, Leo lion says grr. Or people like to go oil rig. Oxidation is loss, reduction is gain. Whatever helps you remember early on, use it. By the time we get around to tests, you shouldn't need Leo the lion says grr. So if we look at some simple half reactions, if I have Cu becoming Cu2+, I've got to balance this out. I have to balance it out by adding electrons. On the left, my charge is 0. On the right, my charge is +2. Whatever side is the higher charge, I've got to bring the charge down. So I've got to bring that charge down from +2 on the right to 0. I do it by adding electrons. So I add 2 electrons, and now I have a balanced half reaction. Electrons are on the right, so this means it must be oxidation. And there we go. That's why it says oxidation. Well, you can kind of guess. If that was an oxidation reaction, as an example, this one probably is going to be reduction. Here we have Cl2 becomes Cl-. First of all, our chlorine atoms are not balanced. We have 2 here. We need to get 2 there. So now we balanced out the atoms. Next thing we have to do is we have to balance the charges. So here's our 2. 2 times 0 is 0. 2 times -1 is -2. So in this case, we have a charge of 0 on the left. In this case, we have a charge of -2 on the right. We've got to bring the left down by 2. So we're going to add 2 electrons on the left. And in fact, if you didn't trust me, you could look at your table of reduction potentials, and this one happens to be there. So you'd have no problem. We know this is reduction because we're going from 0 to -1. 2 of these -1. We've had a drop in charge, and therefore this is definitely reduction. So hopefully that's a simple introduction to a simple concept, and we will get to more complicated stuff momentarily.